Okay, here we go. Here we go. Here we go. Quiet. Okay? Quiet. Okay? I'll take away the classwork credit. That's all. That's my way. I'll leave a note in Aspens for a parent to see. Wouldn't be quiet during the lesson. Taking away points. Okay. Scatter plots. The one thing about scatter plots is I've seen scatter plots before where they make that all one word. You know, scatter plots like that. But in the book they do it 2 words, so I did 2 words. Okay, so scatter plot. Right. How many points do we need to determine a line? 2. Okay. Not only does that make sense like visually, we know now like we can make the equation of a line. You give us 2 points, we'll find the slope, we'll use 1 point and the slope, and we'll come up with your equation. So it's all we need. How many points are actually on the line? Infinitely many points, right? Those 2 are just the only 2 we need to determine where it's at. Okay. So what if you got more than 2 points? Like in this case, I got 3 points. 1, 1, 3, 4, and 6, 6. Now let's see what happens if I graph these things. 1, 1, 3, 4, and 6, 6. Okay. Can I connect all those with a straight line? Let me make my line dashed and blue. So if I tried to like draw a line that connects these 2, it'll miss that point. If I draw a line that connects these 2, it'll miss that point, right? If I go back here, if I hit those 2, I miss that point, right? So if I got more than 2 points, unless all those points are exactly on the same line, then you can't use a straight line to connect them. Right? See what's on the next. So if you have more than 2 points and they're not all on the same straight line, you're going to have to draw the best line you can. We still want to use a straight line, but we're going to have to draw it so that it doesn't necessarily touch any of the points, but it looks like it's like right in the middle of those points. Okay, now if you plotted those points, let's say you had graph paper and you plotted those points, and John drew his best line through those points, and Felicity drew her best line through her 3 points, and everybody did the same thing, we wouldn't all have the same line. We would have a line, but it wouldn't necessarily be the best line that goes through those points. So a lot of what we're trying to do is, how do you come up with the best line that goes through those points? Okay, so before you can determine whether or not it's even reasonable to make a line that approximates your points, they got to actually look like they belong on a straight line. So these are copied out of the book. I had to actually take a picture with my cell phone and then import it. So it's a little bit dim. But you can still see. You could also turn to the book section 5, 6 and see the same graph. But you see on this example right here, there's a whole bunch of points. And it looks like they're pretty closely hugging that line, that straight line. Right? So when you've got points and they look like they could be approximated by a line, you say there's a correlation. Right? There's a correlation. Right? So you see this one definitely looks like a line is a pretty good approximation, so it's a correlation. On this one, same thing. Right? But then when you get onto this one, that just looks like a random bunch of points. So it's not reasonable to think that we could use a line to approximate them. So that would not be a correlation. Okay, or it would be really, really, really weak correlation. So if the line that you use to draw in the middle of your points has a positive slope, then it's a positive correlation. If the line that you draw has a negative slope, then it's called a negative correlation. So before we can decide whether to make a straight line that approximates our data, we got to decide whether or not it looks like there's a correlation. So that's got to be our first step. How do we make a graph and determine whether or not there's a correlation? Okay, try to describe these two. Do those two look like there's correlations? Do they look like that a straight line is, they're pretty close to being a linear relationship? Yeah, it does look like it. Maybe I could use, if I drew this one, it'd be like that. Maybe this one would be like that. That moved on the last second, something like that. Okay. So it looks like there's a correlation. What kind of correlation? For the one on the left, letter A, was it positive or negative? It's positive because the line goes up. And the second one, negative, so the line goes down. So these are graphs of, the one on the left is test scores as a function of hours of studying. So we're trying to determine, like, is there some relationship between test scores and hours of studying? I mean, what would your guess be? Do you think your test score goes up when you study more? Yeah, so that's a positive correlation. You would expect that the more studying you do, the higher your test score. Okay, do you think test scores go up or down based on the number of hours of television you watch? Probably down, right? So that's why the negative correlation there. Okay, so this is just taken right out of the book. It says, predict the test score for a student who watched 4.5 hours of television. Right, how do you think we could predict that test score? Which graph are we looking at now, A or B? We're looking at the B, okay? Where is 4.5 hours of television? Which axis do I look at? The x-axis. This is 4, this is 6, so that's 5. That's 5, so it's about right there. That's 4.5. So we're going to go up to the graph, and then we take that over to the left. What does that look like the value is? About 75. So it looks like it's about 75%. So if you want to do better on the test, watch less television and study more. What a concept. Do we need scientists to tell us this stuff? By the way, they have these new test scores out. There's international tests that are given every few years. And you've probably heard in the news before when, oh, look at America, we do so bad. We were like 25th the last time these scores came out. The new ones came out. America is 39th. We dropped. Singapore's tops. Finland is right up there. South Korea.
And I need to go to Singapore. Yes, you do.
Get ready to work hard if you go over there. But so anyways, here's a table that shows the lengths in centimeters and the swimming speeds in centimeters per second of 6 fish. So do you think, quiet please, do you think that there should be some kind of correlation between the length of a fish and how fast it could swim? What do you think it would be? Bigger means faster?
Bigger is probably slower.
Bigger, okay. Well, here's a bunch of data they collected, so let's graph it and see what it looks like. Okay, so the first one, let's see, we're putting the length of the fish on the x-axis, and we're putting the speed of the fish on the y-axis. So let's see, the pike is 37.8, that's about right. These are every 5, so that's about right there. And it goes up to 148, which is about right there. Okay, the red gurnard, which I've never heard of, has a length of 19.2, that's almost 20. And its speed is 47, that's almost 50, so it's about right there. Right, the black bass, 21.3, a little bit to the right of that, and up to 88. And the gurnard is 26.2, that's about there, up to 131, which is, that'd be 125, so maybe about right there. And then finally, Norway haddock, 26.8 and 98. So that would be about right there. Okay, does it look like that's kind of linear?
Yeah.
Kind of. Probably not as strong as the ones that they gave us as examples, but it looks like there's something of a correlation. So let me draw a line, maybe like this. So when you draw your line, you're trying to make it so, you know, there's like just as many points on one side of the line as the other. So we only had 5 points. So we got 2 on one side, 3 on the other. It's probably pretty close. What kind of correlation does that look like? It looks like it's a positive correlation. That it looks like the longer the fish, the faster it goes. At least for these 5, right? These 5 could have been cherry-picked to show something. Callie said something about the strength of the fish. Yeah, I mean, there could be other factors that make a fish go faster. But this is just trying to analyze this one. Now, one important point, which is beyond the scope of this class, but you're going to hear about correlations in the news. I mean, it comes up all the time. What you can never say for sure when you get a correlation is that there's a cause and effect. Like that means that length causes speed. You're never supposed to go there, and they do that all the time in the news. But still, that just says there might be something there, but somebody would have to do an experiment, a very well-designed experiment to try to prove this thing. Try to eliminate every other factor that you thought might have been causing it, and then do you still have the same correlation? Now, if we were going to make the equation of a line, right, what they would have us do, and they would have us do this in the book right now, okay? And if you don't have a calculator because you're doing this at home, then by all means, you're going to do it like this. You take a couple points on that dashed line that I just drew. For example, what is this point, and what is this point? Because they go through an intersection of grid lines. Let's see, this one is, the x value is 35, and the y value is 150. Okay, and then what about this point over here? The x value is 15, and the y value is 50. So if you can identify a couple points on the graph, you can make the equation of a line. I mean, that's what you did in the homework last night. Here's 2 points, make the equation of a line. So we could do that, right? The m is going to be 150 minus 50, which is 100. 35 minus 15, which is 20, so it looks like the slope is about 5. That's nice and convenient. Okay, and then from there I need to come up with the b, or I'm going to use the point slope form. Y minus 50 equals 5 times x minus 15. Right, that's how we use that. And now solve for y. Y minus 50 equals 5x minus 75, add 50, y equals 5x minus 25. And, okay. Yeah.
When you get your slope, can you do the y?
Yes, absolutely. You can do either way you wanted to get that. Ultimately, we want to have this line. That's a function. That's telling us the speed of a fish is the function of its length. I mean, it's a model. Right? We know that model doesn't actually touch any one of those points, so it wouldn't be an exact predictor. But like if you get a new kind of, maybe there's a red bass, and it's got a different length, you could plug it into the model and say, this is what I think its speed would be. I mean, that's what you do in science. That's what you do. You gather a bunch of data, look for a correlation, and try to make an equation and see whether it has any predictive value. And ultimately, that's what we're going to do. But now, like I say, if all of us did this ourselves, we might come up with 25 different lines. Which is the best line? Maybe none of them. Maybe there's a 26th line, which is the best. So ultimately, we're going to be using our calculator, and it will make sure that we all get the same line, and it's the best approximation possible. Okay. So before we can make the equation of a line, we've got to make a scatter plot so that we can actually look at the data and tell whether or not a straight line is appropriate. So you need to take out your calculators now, right? Everybody, get your hands on a calculator. I'm showing you how to do these things. So in order to make the scatter plot with the calculator, if you notice on the calculator, let me grab one. Why do you have 2? Okay. So stat is right about there. I mean, I put it on, I circled it in red here, but on your yellow calculators, it's in the same position, stat. So you hit stat, and you notice on the top that it says edit and calc and test. Okay, we want edit. So you could either hit enter or 1, either one, and you should get a screen that looks like L1, L2. Does everybody get L1, L2?
Yeah.
If you don't get it, then you might want to clear your, like if you got something else in front, like somebody's put some numbers in there, then you clear the memory. Second plus 712. But everybody should have a blank L1 and L2 in front of you. Okay, the L stands for list. Okay, so usually if you get data, you're going to put the X values under L1 and the Y values under L2. Right, that's how it works. So stat edit, and I think I got some data. So let's do the same thing now with this fish data. Right, there's the data on the screen. Put those values, the length values go under L1 and the speed values go under L2. So it should look just like my screen up there. Right? Every time you enter a value, you hit enter and it goes down. Enter, right? And then on the last one, when you put in the 26.8, you right arrow to go into the L2 column. And all we want to do is just look at the scatter plot, right? We don't want to have to hand plot these things. So you're going to go second y equals, right? Second y equals, and it should say stat plots. And it probably says next to the number 1, it says off. So you want to hit 1 so you can get in there and turn that on. If this is just the start, if it's too much, then I'll just write your F in the grade book right now, okay?
I'll just go to sleep.
Okay? So you need to turn it. It needs to be on. The cursor needs to be on on. You hit enter so that it stays on on. Right now it's on off. So okay, quiet please. Okay, we're going ahead. So again, if you to look at the data, you got to go second y equals 1. Make sure the plotting of points has been turned on, right? And then you go zoom 9. If you go down the zoom menu, zoom 9 means zoom stat. It zooms to the points you just put in. Okay. Now, if you want to go back to the regular graph, like later on, you go zoom 6. That gets you back to the middle of the thing. But right now, we want it on zoom 9. So we look at that, and does that look like it could be linear? I mean, it's the same thing we did by hand before. It's not great, but it's a correlation. Looks like it's a positive correlation.
Mr. Callahan.
Yeah.
My calculator still has that problem. It said variable before I use second.
Okay, use a different calculator. Yes. No. Wait till we finish this. How are you going to know how to do any of this stuff? Right? Quiet. We're not done. We just started. Right? And if you don't sit here and if you're not writing down steps, then I'm not going to repeat this stuff ad infinitum. Okay, so let's make a scatter plot. Let's do the same thing with those data right there. Right? So go ahead and try to make your own scatter plot with these. The X values are going across. Remember, the X values go under L1. The Y values go under L2. Stat edit to enter those, and then second y equals 1. If you already turned on the plotting of points, you don't really need to do that again. You just have to zoom 9. Yeah. If you want to know how to clear the points, you go like this. You go stat, edit, and if you have points in there, you arrow up into the top margin, and then hit clear, enter. That clears that. Or you could just hit delete, 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 delete until it gets, or you could just overwrite them. Okay. So if there is a correlation, then you want to make the best fit line. Then you do this. You go back to the stat. Then you arrow over to the calc. Remember on the top of the menu it said calc? And then you hit enter 5 times. See? Because when you get to this screen, the cursor is all the way up here. So each time you hit enter, it moves down a line. Then when you get all the way to the bottom, and you hit enter one more time, and you should see a screen that looks like that.
I got this.
It might be different than, okay, you did stack calc 1. Stack calc 4.
Oh, 4.
So this is stack calc 4.
Oh, I thought you got. Oh, yeah, I got it. Oh.
Arrow over to the calc and hit 4, right? In that menu, the 4 means linear. 4 LIN, regression. Guys, so everybody should come up with this same screen. Y equals AX plus B, and then it tells you the value of A equals 0.9487, B is 1.615, etc. Is everybody getting to that screen?
Yes.
Okay. So you can write this down then. Here's the equation. Let's round it off to 2 decimal places. Y equals 0.95x plus 1.62. Okay, so when you get to this point, okay, quiet. When you get to this point, you got to write down the equation. Write it down on your paper to have. You'll need it later. Okay, there's a more complicated way to have the calculator save it, but that's too many calculator steps for today. What's that? So you write down your equation. Okay. Now go to the y equals button on your calculator and put that equation on line 1. 0.95x plus 1.62. Okay. And now go back to the graph, and you see that your line now is going like right through those points. It looks like there's 5 on one side of the line and 4 on the other.
That's lit. I see it.
Yes. Did you do this? Did you get the line going through the middle of the points?
It was hard.
Okay, let's do another one. We're going to do another one. The table shows the number of active red-cockaded woodpecker clusters in a part of the DeSoto National Forest in Mississippi. Write an equation that models the number of active clusters as a function of the number of years since 1990. Okay, well, let's see. Here's our data. The years 1992 all the way up to 2000. But we want our x value to be the years since 1990. So in 1992, what will be the x value? Since 1990. 2. In 1992, it's 2 years after, right? So this is what you're going to put in your L1. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then for the clusters, you use the 22, 24, all the way up to 51. So go ahead and try to enter those in the calculator. Remember, stat edit, put in all those values. For L2 will be 22, 24, 27. right? These are the L. This is what goes under L1, the blues, and then this is what goes under L2.
This right here. That one is cool. It should be 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's start out with 22. She be even.
Smooth mountain after you get to
I would do 22. Yeah.
Yeah.
If you're not even, Mike,
So, when you've entered the data, listen up. When you've entered the data, go to y equals. If you put the equation on y equals from the last one, clear that out of there because you don't want to look at that line. So just clear it. Right? So that's blank. And then do another zoom 9. Make it zoom to the data you just put in. And see what it looks like. See if it looks like it's a. Okay. So if your data, did your data look like it was mostly linear? Yeah, it was a pretty good, probably better than the last one, better than the first one. So what are the steps to actually make that equation now? Stat, calc, for, enter 5 times. Remember? Stat, calc, for, enter 5 times, right down the line.
1, 2, 3, 4, 5, 6. Good one, enter.
Oh, like that?
So
Now you go
You just press y equals.
4. Now you do it again. Stat, calc,
You
for.
must do it graph. Graph. Yeah, you did.
where's the equation on? Y equals
Why isn't there a line on
Huh?
You can write it down. You can write it down.
Oh, you got to
Write it down. And then Y equals, type it in.
You probably did.
Okay, quiet. Listen up. So if you did this, you should have gotten this equation. Everybody should have gotten pretty much the 3.7. That was the slope. I rounded to 12.5 for the y.
Yeah, I got it.
Right, that should. So again, you can go to your y equals and put that on y1, and then see if it goes right through the middle of your points.
Could you put 4?
Yes.
Right now,
I mean, you could graph it yourself.
Could you put 4 in? Mr. Callahan, can you put 4x or half?
Everyone knows. Put in 3.7.
Oh, wow, you're so cool.
And then you'll be at 3.7.
Oh, you're so cool.
You should see your line.
Hold on, you gotta do it in microphone. Press 10.
So again, if you go to y equals and you put that in, you should see your hit graph. You should see your line going pretty much through the middle of those points, which means you get a good line. It's called a linear regression. It's a statistical term. Okay. 2, 3, 4. 1, 2, 3, 4. Okay. Okay, try one more.
Fun.
I'm lying. Y'all want to.
What did you do?
You made it. That's a huge deal.
What's up? I need to find a
Yeah, mine has a
Mr. Callahan.
Yeah.
I need my count.
I think all of ours has like a line in the corner. It's just like a continuous line.
Let me see.
I think everyone has that.
Oh yeah, guys.
If you have a line on your graph already, it's because you can go to y1. You still have an equation there from the last problem. Zoom 9. So you should have gotten a graph that looks kind of like that, right? And then how do you make? What are the steps to find the equation of the line then? Stat calc 4. So stat calc 4. Yes. That's good. So that's the final result, right? We did a scatter plot, we made a best fit line, and we graphed it right through the middle of our points.
Yes.
See, I told you.
I do.